Let's talk about limiting and excess reagents within the context of stoichiometry. Please note that this is an optional topic in Chemistry 20 in Alberta. Before we talk about chemistry, let's compare this to a real-life analogy. And my favorite analogy is hot dogs and hot dog buns. In a typical package of hot dog wieners, there are 10 wieners, but in a typical package of hot dog buns, there are only 8 hot dog buns. Therefore, often we're left with an excess of hot dog wieners, 2 excess wieners, or we can also say that we're limited in the number of hot dog buns that we have. We can apply this concept to chemistry as well. So if we're to apply the concept to chemistry, we can look at one of our more simple equations, the formation of water from hydrogen gas and oxygen gas. This is our balance equation. 2 moles of hydrogen plus 1 mole of oxygen gives you 2 moles of water. If we're looking at an example here, we see that we have 4 molecules of hydrogen gas and 3 or 1.5 atom molecules of oxygen, so that's 3 atoms. And here we have 8 atoms of hydrogen. Now, you can clearly see from our product here, we have 3 molecules of water, and we have 2 extra hydrogen molecules. Right? So we know this is our extra or our excess reagent, and we're limited by the number of oxygen that we have for our reaction. So in this case, our limiting reagent, O2, is our oxygen, and our excess reagent, ER, is our hydrogen. So if we're to do this in the format of a chemical calculation, the first thing we need to do is determine which entity, which compound, is our limiting reagent. And in order to do that, we have to do a first round of initial stoichiometry calculations. From that first round of calculation, we can determine which chemical is our limiting reagent, and then use the amount of that limiting reagent to solve our question. So let's do an example. In the formation of water, so water is our product, from hydrogen gas to oxygen gas, so hydrogen gas and oxygen gas, 10 grams of hydrogen and 20 grams of oxygen, that should say oxygen there, is present. What is the maximum mass of water that could be produced? So let's list our variables. So we know we have 10 grams of hydrogen and we have 20 grams of oxygen, and our molar mass of hydrogen is 2.02 grams per mole, and molar mass of oxygen is 32 grams per mole. And at the end of the day, we want to find the mass of the water, so we might as well look up the molar mass of water, which is 18.02 grams per mole. Okay, so it doesn't matter which compound you start with, and just for random sake, we'll pick hydrogen gas. So we have hydrogen gas, 10 grams, and convert that into moles by dividing by the molar mass. Then we follow our mole ratio to find how much oxygen we need to completely use up the hydrogen. So we use our mole ratio for oxygen and hydrogen, and then multiply by the molar mass of oxygen. And just to make sure our units cancels out, we have moles there, and then grams of hydrogen, and then lastly we also have hydrogen that get cancelled out, leaving us with 79 grams of O2 is needed. So we have our number here. We need 70 grams of oxygen to completely react our 10 grams of hydrogen. However, we notice that we only have 20 grams of oxygen present. So we say, but only have 20 grams present. So then we know that O2 must be our limiting reagent because we don't have enough to completely react our oxygen, or our hydrogen. So now, let's now do stoichiometry using the amount of limiting reagent, in this case oxygen, to solve our question. 20 grams of oxygen divided by the molar mass of oxygen, which is 32. And then the mole ratio between water and oxygen, we have 2 water for every 1 oxygen. And now to multiply by the molar mass of water, 18.02 grams for moles. Let's check our units. Grams, grams, oxygen, oxygen, moles, moles. So we have grams of water, and the number there comes out to be 23 grams. So we can make 23 grams from 20 grams of oxygen, which is our limiting reagent. So the key here was that we did a first round of stoichiometry in blue here to determine which reagent is our limiting reagent, and then using that limiting reagent to calculate the maximum amount of product that can be formed. We can also look at these questions from a slightly different perspective. So our example here is in the formation of ammonia from nitrogen and hydrogen, 5 grams of hydrogen and 15 grams of nitrogen is present. What mass of the excess reagent is left over once all of the limiting reagent is used? So this is worded differently than our previous question. However, we can start off in pretty much the same manner. All right, so we'll list off the information. 5 grams of hydrogen, and the molar mass is 2.02 grams per mole. And then for nitrogen, we have 15 grams, and it is 28.02 grams per mole. So again, the first thing we need to do is figure out which is our limiting reagent. So let's start with 5 grams of hydrogen, convert that to moles, 2.02 grams. And now to see how much nitrogen we need to completely react at 5 grams of hydrogen. So our mole ratio here is 2 moles of nitrogen over 3 moles of hydrogen, and then multiply by the molar mass of nitrogen, 28.02 grams, 1 mole. And then our math says we have 46 grams of N2 is needed to completely react with our 5 grams of hydrogen. However, we only have 15 grams. So this must be our limiting reagent. So just as before, let's do some math with our limiting reagent. So we have 15 grams of nitrogen gas. Convert that into moles by dividing by the molar mass. Now we need to find how much of the hydrogen we're going to use up. So now we go with the mole ratio for hydrogen on top and nitrogen on the bottom, and then multiply by the molar mass of hydrogen. Double check that our units cancels out. Nitrogen, nitrogen, moles, moles. So indeed it does. And then our calculation tells us we need 1.6 grams of H2 is needed. But if we notice here, we have 5 grams of H2. So the amount of excess is what we started with, 5 grams, minus what we need, 1.6 grams, so that we have 3.4 grams of excess hydrogen at the end of the reaction. So hopefully that clears up the concept for you a little bit. If you need a little bit more reading and a little bit more practice, please check out this online textbook. It is an excellent resource for you to use.